Welcome back for the second part of the Ameribrade 272 belt grinder. In the first video we talked about assembly. Today we're going to talk about operationalizing your belt grinder and melting some metal. One of the things that we'll accomplish today is changing out the drive wheel. First video we talked a little bit about the 4-inch and 7-inch drive wheels and how that gives me some variability associated to a fixed 1.5 horsepower motor. Now in the first video, the assembly portion, we went over what I purchased from Ameribrade, which included the plug-and-play motor. We will discuss motor mount, assembly, motor assembly, and aligning the motor with the frame so that you have a nice true drive. We'll go over some tools. We'll swap out the 7 and 4-inch drive wheel with an 80-inch ceramic belt that I also purchased from Ameribrade. We'll melt some metal, and then last part of this video is I'll do a drive-by and just let you see up close some of the components and the craftsmanship. Last but not least, I will take a small shot glass of water and place that right here while I fire up the machine, just to talk about any vibrations or anything that we see. Now in the first video we talked a little bit about keeping the bolts and nuts that came as part of the packaging. I've done that, and I've used those exact nuts and bolts to mount that to my workbench, which is really just 3/4 inch plywood on some 2x4s. What we can draw our attention to next is the drive wheel. This is the 4-inch drive wheel. We'll start with that first, and then I'll put on the 7-inch. Now, I talked a little bit about variability and changing out the drive wheel. So let's go ahead and do that to see how easy it is. You will be supplied an Allen wrench. That Allen wrench will just go down the hole. It aligns essentially over the drive shaft where you'll see a bar stock that's used to keep the wheel from slipping. So we're going to slide that off. Make sure that our Allen is nice and loose. Now that we have the drive wheel off, we can pull apart the bar stock and show that to you. So that gets placed in the counter shaft, or the drive shaft. So once that's in the drive shaft, you'll notice in the drive wheel there's a nice little notch in there. And this is an example of an Ameribrade wheel. It's very nice. This is the 4-inch. We're going to put that back on the drive shaft again. Tighten that down. Now, I like to put my finger over that little bar stock to make sure it doesn't slide. And then you just want to get a nice tight. You don't want to over tighten it and strip that. So now that's how easy it is to change out a drive wheel. It's pretty simple. When you unpackage the motor, you will see this in there. There's also a video on Ameribrade, talks about the exact same thing. This is used to align the motor to the frame. And really what you're doing is using the front end of the drive wheel assembly and making sure that's parallel to the frame. Pretty simple to do. You just take this piece of material, place that against, and make sure the tolerances are the same. It aligns with the drive wheel as the same as it does for the frame. Once you've done that the first time, you're set, because it doesn't matter if I change out the drive wheel, they're the same widths. So the alignment is the same because it's the circumference of the wheel. Now when we are getting smaller and larger, we will have to make some adjustments on the belt, but it's, as you see, it's very simple to do. What I'm going to go ahead and do is mount up a belt, and we'll get that started. First test we'll do is we'll look for vibrations, and after the vibration test, we'll mount on the assembly, talk a little bit about changing an angle, and we'll start melting some metal. Now we're going to go ahead and mount up a belt. First thing I wanted to show you is how that you create the tension. You notice the construction springs back here create tension for the drive. This locking mechanism allows you to take this really nice handle and pull that down to create the lock. Now I can go ahead and mount my belt. Now I'll unlock the tension. Just reach inside of here, pull down. First thing we're going to do is make sure that the belt is true. Let's go ahead and look at that. What I'm going to demonstrate now is a vibration test. We'll go ahead and put that shot glass of water top of the main frame where we have drive assembly, and I'm going to turn it on. This is the point of the video, you may want to put some mute on. As you can see through the vibration test, once this is firmly mounted to your work structure, it runs pretty true. It's very well balanced. Obviously, without minimal vibration, you saw how the shot glass stayed pretty center trued and aligned. It's pretty impressive. I've already done some work on this, about 3 to 4 days, and I'm highly impressed on how it works. Let's talk a little bit about what you see here today. We do have the ability to work with a tilting platen. What I prefer to do is work by tilting the work assembly. I'll talk a little bit about that. First, I'll put the assembly in. It's pretty simple to do. Once it's mounted, you use the knobs. Bring it here, nice and true, as you see the assembly. The assembly also gives you the ability to work with an angle of deflection. That's a little bit what I was talking about. You do have the ability to work with the tilting platen as well as a tilting assembly. To find an angle that I work to, let's say use a bevel on a knife, I went to a store online that sells a lot of goodies and bought myself a digital angle finder. It's pretty easy for you to go ahead and turn on the angle finder. Find yourself a 20-degree angle. Now on the camera looking backwards, it's going to look 50, but that is a 20-degree angle. Now that you have a 20 degree, it's pretty simple for you to put that on top of the assembly, and then working with a level across the middle. Once this is level, this will be at 20 degrees. You can crank this down, and now you're working with a 20-degree angle. Felt that's really easy to work with. Even doing this by myself, it's easy for me to control the angles, work with the work assembly. Now to talk a little bit about the tilting platen, you do have some limitations on how far, let's say, the platen can be pulled at an angle as with the work assembly. That's why I felt like I like to keep this at a nice right angle and then work with the assembly to get myself the bevel that I like. I'm going to go ahead and work with the right angle, tighten that up. Next thing we're going to do is grab some bar stock and run a grind. Alright, so I went ahead and just fired it up and started to put some grind on some metal. Just to let you know, this is just some rough stock I got from Lowe's. This is no high carbon. What we have is some 3/16. It's about a 1.5 inch cross. It was originally 3 foot stock. What I was doing is just working down towards a, let's say, 20-degree angle, simple plunge line, started to melt some metal. With the 4-inch, it gives me a little bit more control. Again, it was pretty simple for me to start grinding through this without any issues. This was an 80 grit ceramic that I also got from Ameribrade. Now, for interest of time, to make sure we fall under my limits, when I put the 7-inch wheel, it chews through this at an alarming pace. I almost prefer using the 4-inch on, let's say, my smaller stock, 8-inch, if I'm doing paring knives. But if I do go for a 3/16, I can go to the 7-inch and chew through this pretty quickly, depending upon the bevel and what I'm looking for on speed. They're both impressive when paired together. Again, doing the 4 and then switching to the 7 is pretty easy, as we showed, taking off that drive wheel. But this was just some basic grind with some plunge line, working on an angle, and it is pretty easy for you to work through it. Last but not least, let's just take you through a drive-by. Again, just to point out, anything that you wanted to do to make sure that belt is true, you have full capabilities working here, and that just essentially sweeps this in or out to make sure that this belt is aligned. Very easy for you to go ahead and take a belt off. Again, for us, we would just work with the locking mechanism. Once you pull that down, it's self-engaged and the belt is easy for you to take off. Pretty amazing engineering. We can work through one last time to see some of the work assembly. We again have the tilting platen that I didn't get to, but we can do that in the next video. Hopefully this was some more information to get you started. I really enjoy working with the machine. It's amazing. Thanks again for watching the video. If you like it, that's great. Any information that helps you out, that's amazing. If not, we'll see you next time.